From Isaac Newton's Principia, 1687. The famous laws of motion in this extract come near the beginning of the Principia, immediately after the definitions, indicating the similarity in plan of the work to that of Euclid. Much has been written about the true meaning and implications of the laws on which classical physics is built. Axioms, or laws of motion. Law 1. Every body continues in its state of rest or of uniform motion in a right line, unless it is compelled to change that state by forces impressed upon it. Projectiles continue in their motions so far as they are not retarded by the resistance of the air or impelled downwards by the force of gravity. A top whose parts by their cohesion are continually drawn aside from rectilinear motions does not cease its rotation, otherwise than as it is retarded by the air. The greater bodies of the planets and comets, meeting with less resistance in freer spaces, preserve their motions both progressive and circular for a much longer time. Law 2. The change of motion is proportional to the motive force impressed, and is made in the direction of the right line in which that force is impressed. If any force generates a motion, a double force will generate double the motion, a triple force triple the motion, whether that force be impressed altogether and at once, or gradually and successively. And this motion, being always directed the same way with the generating force, if the body moved before, is added to or subtracted from the former motion, according as they directly conspire with or are directly contrary to each other, or obliquely joined, when they are oblique, so as to produce a new motion compounded from the determination of both. Law 3. To every action there is always opposed and equal reaction, or the mutual actions of two bodies upon each other are always equal and directed to contrary parts. Whatever draws or presses another is as much drawn or pressed by that other. If you press a stone with your finger, the finger is also pressed by the stone. If a horse draws a stone tied to a rope, the horse, if I may so say, will be equally drawn back towards the stone. For the distended rope, by the same endeavour to relax or unbend itself, will draw the horse as much towards the stone as it does the stone towards the horse, and will obstruct the progress of the one as much as it advances that of the other. If a body impinge upon another, and by its force change the motion of the other, that body also, because of the equality of the mutual pressure, will undergo an equal change in its own motion towards the contrary part. The changes made by these actions are equal, not in the velocities but in the motions of bodies. That is to say, if the bodies are not hindered by any other impediments. For, because the motions are equally changed, the changes of the velocities made towards contrary parts are inversely proportional to the bodies. This law takes place also in attractions, as will be proved in the next scholium. Newton here explains that the cause of the revolution of a planet is the same as that of the fall of a stone. The centripetal force to which he refers is gravitational attraction. The principle of circular motion in free spaces. After this time, we do not know in what manner the ancients explained the question how the planets came to be retained within certain bounds in these free spaces, and to be drawn off from the rectilinear courses, which, left to themselves, they should have pursued, into regular revolutions in curvilinear orbits. Probably it was to give some sort of satisfaction to this difficulty that solid orbs had been introduced. The later philosophers pretend to account for it either by the action of certain vortices, as Kepler and Descartes, or by some other principle of impulse or attraction, as Borelli, Hooke, and others of our nation. For, from the laws of motion, it is most certain that these effects must proceed from the action of some force or another. But our purpose is only to trace out the quantity and properties of this force from the phenomena, and to apply what we discover in some simple cases as principles by which, in a mathematical way, we may estimate the effects thereof in more involved cases, for it would be endless and impossible to bring every particular to direct and immediate observation. We said in a mathematical way to avoid all questions about the nature or quality of this force, which we would not be understood to determine by any hypothesis, and therefore call it by the general name of a centripetal force, as it is a force which is directed towards some central. And as it regards more particularly a body in that centre, we call it circumsolar, circumterrestrial, circumjovial, and so in respect of other central bodies. The action of centripetal forces. That by means of centripetal forces the planets may be retained in certain orbits we may easily understand, if we consider the motions of projectiles. For a stone that is projected is by the pressure of its own weight forced out of the rectilinear path, which by the initial projection alone it should have pursued, and made to describe a curved line in the air, and through that crooked way is at last brought down to the ground. And the greater the velocity is with which it is projected, the farther it goes before it falls to the earth. We may therefore suppose the velocity to be so increased that it would describe an arc of 1, 2, 5, 10, 100, 1,000 miles before it arrived at the earth, till at last, exceeding the limits of the earth, it should pass into space without touching it. Let AFB represent the surface of the earth. C its centre. VD, VE, VF, the curved lines which a body would describe if projected in an horizontal direction from the top of an high mountain successively with more and more velocity, and because the celestial motions are scarcely retarded by the little or no resistance of the spaces in which they are performed, to keep up the parity of cases, let us suppose either that there is no air about the earth, or at least that it is endowed with little or no power of resisting. And for the same reason that the body projected with a less velocity describes the lesser arc VD, and with a greater velocity the greater arc VE, and augmenting the velocity it goes farther and farther to F and G. If the velocity was still more and more augmented, it would reach at last quite beyond the circumference of the earth, and return to the mountain from which it was projected. And since the areas which by this motion it describes by a radius drawn to the centre of the earth are, by Proposition 1, Book 1, Principia Mathematica, proportional to the times in which they are described, its velocity, when it returns to the mountain, will be no less than it was at first, and retaining the same velocity, it will describe the same curve over and over by the same law. But if we now imagine bodies to be projected in the directions of lines parallel to the horizon from greater heights, as of 5, 10, 100, 1,000 or more miles, or rather as many semi-diameters of the earth, those bodies, according to their different velocity and the different force of gravity in different heights, will describe arcs either concentric with the earth or variously eccentric, and go on revolving through the heavens in those orbits just as the planets do in their orbits. This well-known passage comes from the General Scholium at the head of Book 3. In it, Newton states the objective of science. Following the lead given by Galileo, he maintains that science must be experimental and inductive, in contrast to the deductive method of Aristotle. He says that he frames no hypotheses. The hypotheses he is condemning in particular are those of Aristotle's occult qualities and of Descartes' mechanical vortices. Nevertheless, hypothesis has an important place in scientific method, and Newton himself showed an extraordinary imaginative fertility in his queries at the end of his Optics. But hitherto I have not been able to discover the cause of these properties of gravity from phenomena, and I frame no hypotheses. For whatever is not deduced from the phenomena is to be called an hypothesis, and hypotheses, whether metaphysical or physical, whether of occult qualities or mechanical, have no place in experimental philosophy. In this philosophy, particular propositions are inferred from the phenomena, and afterward rendered general by induction. Thus it was that the impenetrability, the mobility, and the impulsive force of bodies, and the laws of motion and of gravitation were discovered. And to us it is enough that gravity does really exist, and act according to the laws which we have explained, and abundantly serves to account for all the motions of celestial bodies and of our sea.